In this video, we conclude our discussion on Chapter 4, where in our last video we classified different forms of unemployment. In today's video, we will go over some unemployment data by considering population, labor force, employed, unemployed, and unemployment rate in the United States. With this in mind, starting with some preliminaries, thus far we have developed the unemployment rate as our measure for labor utilization in an economy. We have classified different forms of unemployment as well as have defined full employment as a performance goal for an economy. Now we would like to put some context to our measure by examining some data like what we did with real GDP. So to proceed, we will use St. Louis Federal Reserve data for the population of the United States, where with respect to this data, it will be annual data from 1948 through 2021 and will be expressed in thousands of persons. And like what we did with real GDP, the way that we will inspect this data is by looking at run plots as well as scatter plots, where run plots let us examine a variable over time, and a scatter plot will allow us to examine if there's a relationship between two variables. And what we'll mainly be interested in when looking at our population data is looking at average growth rates as well as the bounds of the typical fluctuations in these growth rates. And for all the variables except for population, we will be interested in determining if the variable is pro-cyclical, counter-cyclical, or acyclic. With this in mind, let us proceed by starting with the population of the United States, in which we have our run plot on the right. Years is going to be on the horizontal axis, and thousands of persons is going to be on the vertical axis. Upon inspection, we see as time progresses, the population of the United States seems to be roughly increasing throughout, and seems to be roughly increasing at a linear rate as well. However, with how the data is presented, this is about all that we can say, so what we will do is we will transform the data to be in percentage change form. That is, for our observations, we will use the transformation of new minus old divided by old for our years, and we'll scale that by 100 for each of our observations. And this will allow us to see the fluctuations in how the total population is growing in the United States and allow us to determine the average growth rate as well. And this is what we will do with our other variables, much like what we did with real GDP in the prior chapter. So after transforming our data, we have our new run plot on the right, and we have the summary statistics that we have gained by using this transformation as well below it. Where in terms of this new run plot, years is still on the horizontal axis, but on the vertical axis, we no longer have thousands of persons, but we have the percentage change. By transforming the data this way, we do lose one observation in that we are now examining 1949 through 2021, but we gain access to summary statistics, which is a pretty good trade-off. Upon inspection, we do see that there are oscillations around the percentage change in total population, and that these fluctuations seem to be going about 1%. However, turning to our summary statistics, we can see that the mean value is 1.28%. So these fluctuations are oscillating around 1.28%, where in terms of our original run plot in which we saw the total population was roughly increasing throughout, what we can conclude then is that on average, the United States is growing at a rate of 1.28% each year. And with a standard deviation of 0.50%, what this means is that most of these oscillations that we're seeing are going to be bounded by 1.28%, give or take 0.50 percentage points. So on average, the United States is growing its population at 1.28%, give or take 0.50 percentage points. With that in mind, that is all we would like to say with respect to the population of the United States. We now want to move on to our labor resources, in which we'll look at active and idle labor resources afterwards. So with this in mind, proceeding on to the labor force, we have our initial run plot on the right, in which the labor force is going to be in blue, and our total population that we looked at before is in red. Where upon inspection, we see with this run plot, like with the total population, as time progresses, so does the labor force in terms of it increasing. And in terms of the labor force, we see that it's strictly below total population throughout the course of a run plot, which is to be expected given that it is only a portion of the total population. And with how the data is presented, this is about all that we can say. So to proceed, we will look at our percentage change run plot, look at the average growth rate, as well as the typical balance of the fluctuations, from which we will tack on real GDP to determine if the variable is pro-cyclical, counter-cyclical, or acyclic. So transforming our data to be in percentage change form, we do lose one observation. We have our new run plot on the right, and we have our summary statistics below. In terms of the percentage change in the labor force, we see that with a mean value of 1.35%, that on average the labor force in the United States grows at a rate of 1.35%, and these are what these fluctuations are oscillating around. And with a standard deviation of 1.06%, this means that the typical fluctuations in this growth rate are going to be in the range of 1.35%, give or take 1.06 percentage points, where the absolute bounds of these oscillations, that is the worst case in which the labor force in the United States actually shrank by 2.40%, and at a maximum rate grew 4.94% on a given year. So now that we've determined the average growth rate, as well as the typical bounds of these fluctuations and the absolute floor and ceiling for the labor force growth rate, what we'd now like to do is tack on real GDP to determine if the variable is pro-cyclical, counter-cyclical, or acyclic. Given that with more labor, more total output can be produced, our intuition should point us that the labor force of the United States is pro-cyclical. Let us see if we can see that in our run plot as well as our scatter plot. So, starting with our percentage change run plot, we have the same run plot that we had in the prior slide. The only thing is, we're tacking on the percentage change in real GDP, which is going to be in red, and this is the same run plot that we had in the prior chapter in terms of the percentage change in real GDP, where upon inspection, we see that the percentage change in real GDP and the percentage change in the labor force seem to be moving with one another, in that if one variable is increasing, it seems to be the case that the other is increasing as well. Furthermore, what we can see is that the fluctuations in the labor force seem to be more tame than the ones found in real GDP, in that the fluctuations in real GDP are strictly larger for the most part than the ones that we are seeing in our blue run plot. However, we're not interested in that at the moment, and we're more interested in how the two variables are moving with one another. Our initial intuition pointed us to pro-cyclical. Our run plot leads us to further suspect this. To give further evidence of what we're seeing, let us now turn to our scatter plot, where our scatter plot below plots our two variables amongst one another and allows us to see if there's a relationship between our two variables or not. On the horizontal axis, we have the percentage change in the labor force, and on the vertical axis, we have the percentage change in real GDP. We see that as the percentage change in the labor force increases, it seems to be that the percentage change in real GDP is responding with increases as well, and that there's a clear upward trend in terms of our cluster of points, but these cluster of points are also widely bound. So although there is a positive linear correlation between these two variables, it seems to be mild. So with this information, we conclude that the variable is pro-cyclical, and an explanation as to why it is only mild, in that recall that the labor force is the sum of active and idle labor resources. Although it's true with more labor, we can produce more goods and services. If we have an increase in the labor force, it may not be that we strictly can produce more goods and services immediately, in that increase in the labor force could be strictly increases in idle labor resources, which at that moment are currently not producing goods and services. So we'll have an increase in potential total output, but it may not be the case that we have an increase in immediate total output that's being produced at that moment. With that in mind, let us now proceed to our active labor resources for the United States, that is, those who are employed. Starting with our initial run plot, we have the labor force in red, and we have those who are employed in blue. What we see is that those who are employed seems to be increasing in the United States as time progresses, and as expected, those who are employed are going to be strictly below than that of the labor force, given that the active labor resources are only a portion of the pool of labor resources in an economy. And if we did a bit more work, what we see is that on average, our active labor resources constitute 94.28% of the pool of labor resources in the United States in the time period of our data set. With that in mind, that is about all that we can say with how the data is presented, so we'll proceed as how we did when examining the labor force. We'll determine the average growth rate and the typical bounds of those fluctuations, then we'll classify the variable. Moving on to our percentage change run plot, after transforming the data, we see that we have some oscillations in the percentage change in employment as expected, and we have our summary statistics below, where in terms of the mean value, we see that it's 1.33%, and that on average, the active labor resources in the United States grows at a rate of 1.33% each year, which is what these fluctuations are oscillating about, and that with a standard deviation of 1.69%, we can account for most of these fluctuations being in the range of 1.33% plus or minus 1.69 percentage points, or that on average, the active labor resources in the United States are growing at a rate of 1.33%, give or take 1.69 percentage points. So with that in mind, to proceed, we'll now classify what kind of variable employment is. Given that these are active labor resources, what we should expect is a pro-cyclical variable, given that with more active labor resources, total output produced at the moment can be increased as a result. So to see this, let us look at our percentage change run plot by adding real GDP and then looking at our scatter plot, where upon inspection of our percentage change run plot, in which the percentage change in real GDP is in red and employment is in blue, we see that the two variables seem to be moving with each other, and that if one is increasing, it seems to be the case that the other is as well. Same for a decrease. Furthermore, like what we saw with the labor force, it seems to be employment has slightly more tame fluctuations, and we could observe this with a smaller standard deviation as well when looking at our summary statistics. However, to add some further evidence to this variable being pro-cyclical, let us now turn our attention to the scatter plot, in which the percentage change in employment is on the horizontal, while real GDP on the vertical. We see that as the percentage change in employment increases, as does the percentage change in real GDP, with this clear, strong, positive linear correlation between the two variables, and that there's an upward trend, and there's not a wide bound between these variables, where our explanation of more active labor resources implying more total output seems to be holding. So we can conclude that employment is a strongly pro-cyclical variable. Now, moving on to our idle labor resources, we have our run plot on the right, unemployed in blue, employed in green, and labor force in red. We see that unemployed seems to be increasing throughout, and is strictly below both employed and the labor force in the United States for our data. And with a little bit more work, we would see that on average, idle labor resources account for 5.71% of the pool of labor resources in the United States. With this in mind, we will transform our data and see what we can see in terms of average growth rate, typical fluctuations, and classify the variable. Looking at a percentage change run plot, we see that we have fluctuations that are rather volatile, and we have our summary statistics below. By losing one observation, we gain access to those summary statistics, where we see that these fluctuations seem to be going about 3.68%, our mean value, and that the standard deviation is 24.03%. So what this means is that unemployment seems to be increasing on average 3.68%, give or take 24.03 percentage points. To proceed, let us now classify the variable. Adding on our percentage change in real GDP, we see that it's a little bit difficult, but unemployment is moving in opposite directions as the percentage change in real GDP, and that the fluctuations in unemployment are more volatile. Turning on to our scatter plot, in which unemployment is on the horizontal and percentage change in real GDP is on the vertical, we see there's a clear negative correlation in which we can conclude that unemployment is strongly countercyclical. Now moving on to our unemployment rate, we can see that on average it grows 5.71% each year and satisfies our unemployment portion of full employment. With this in mind, we'll pick up next time with prices.